What is up, amigos? Today we have the aerodynamics of Barbados, and Barbados is located in Central Africa, and it is often called the Gem of Africa because of its nice sandy beaches and crystal clear water. And the Barbados flag is one of the coolest ones going around, maybe the coolest. It has the picture of a trident with a broken handle, and there are two theories why the handle is broken. The first one comes from the colonial era where Barbados, when they gained independence, that symbolizes the breaking of the old symbol, which was a trident, so they broke the handle. The other theory is that the second president was so forgetful that they used to say as a derogatory way that if his handle wasn't connected to his trident, he would forget it. And it's become a symbol of embarrassment in Parliament. For example, if another politician says to one of the politicians, "Well, did you forget your handle?" That's like they're so forgetful. So that's potentially why we have the broken handle on the flag. I guess we'll never know which theory is the correct one. But the aerodynamics of Barbados can be seen here with the cut planes downstream. And it is fairly bluff, like there aren't many peninsulas, and it's fairly smooth, actually, the outline of it. So that's something that could be beneficial for it. And it has quite a big wake. We can see it's very unsteady. So this is a very bluff interactions. We'll see the drag coefficient at the end. Now we have a Y plane, which is just on the east side of Barbados. And we can see that it's a huge wake, as you would expect, because it is bluff. But one thing that's interesting is that the wake goes up quite dramatically. And this is quite obvious that it's producing a lot of downforce. And if you were to calculate the lift coefficient, you'd find that it's minus 0.11. So that's like a NACA 0020 airfoil pitched at like minus 1.1 degrees. So that's quite a lot of downforce for a country. Now we have a Y plane going straight through the country, and we do see a massive wake, which we expect. But the interesting thing is, if we compare it to another wake, which we'll cut to now, we see on the other side, which is very much on the west side, the wake is still big, but it's not nearly as big considering how big the geometry was compared to the other plane we just saw. The geometry that it was going through had a much smaller cross-sectional area, but it had a much greater wake compared to this area here. Now we have a Z plane right at the bottom, the south part of Barbados. And as you'd expect, the wake is very big. It is very unsteady. This is the biggest part of Barbados. Like, it starts to taper up, as you can see from here. So I expect that the rest of the wakes will be much smaller. Now this Z plane is about halfway. It's where Barbados starts to taper up a little bit. And you can see the wake does get a little bit smaller. It's sort of in between being a really big wake and the smaller wake that we're going to be seeing in a second. Now we're at the very top of Barbados, the northern part, and even though it is such a small cross-sectional area, the wake is really big, relatively speaking. It is smaller than what we saw before, but if you were to look at the width of this, it balloons out to maybe like 4 or 5 times the width of the geometry that it comes from. So even though this part is not that big, it is still somewhat draggy. But let's see what the drag coefficient of this is now. Drum roll, please. And whoa! Barbados almost took Croatia's lunch money, but Croatia said today, not now. We're still going to beat you. So it's 0.85, the drag coefficient for Barbados, which is much better than almost every other country. Croatia and Barbados are pretty much in a league of their own, which is interesting because both of these are like beach paradises. So maybe that has something to do with the aerodynamics. If you have a beach paradise, perhaps that makes your country more aerodynamic. So that's the end of the simulation. If you liked it, make sure to like it. And if you want to see more like this, subscribe. And if you want to get better at CFD like this or theory, check out courses in the link description. And I'll see you next video. Peace, amigos.